I'm now moving on to page 210. And for page 210, example number 6, I'm given the graph of f prime of x below. So this is the graph of the derivative. And I need to find all intervals where the original graph, this is f of x, where would f of x be increasing? So increasing means where does it have a positive slope? And I need to justify my answer. Okay, so for this particular problem, let's go ahead and look at my cheat sheet again, which is just below here. So over here, this is my original function, f of x. This is my derivative, and this is my second derivative. Okay, so if I take a look at my very first original function, f of x, ask yourself, where is the original function actually increasing? So where does the original function have a positive slope? Well, it has a positive slope in this region, and also has a positive slope in that region. So here is my positive slope, and there is my positive slope as well. All right, so ask yourself what's happening to the derivative just below it. So on my derivative graph, if I just copy, if I correspond the blue region with the green region, it seems like the green region is above the x-axis. Okay, so the conclusion here would be, if the derivative graph is above the x-axis, then the original graph would have a positive slope. All right, so that's our justification there. So let me just kind of write that down. So if f prime of x is above the x-axis, this would imply that f of x is increasing. So on our graph here, which is the derivative right here, we need to find all regions where the graph is above the x-axis. All right, so this region right here in purple from A to B is above the x-axis, and from D to E we're also above the x-axis. Okay, so since I have an endpoint here, I can write that as A less than or equal to x less than B. So I'm definitely increasing, or I'm definitely above the x-axis there. And since there's an endpoint over here, I can write that answer as being between D and E. So x is between D and E, but E has to be included there because it's an endpoint. So those are my two answers for that particular question there. Okay, let's move on to the next one here. All right, so for question number 2, I need to find all intervals where the graph of f, the original function, is concave down, and I need to justify my answer. So remember, we're given the derivative, right? So let's go ahead and take a look at our cheat sheet. Here is the original function, and here is my derivative. So I need to find out where the original graph is concave down. Okay, so on my original graph, if I take this purple region right here, that looks to be the concave down region. And then ask yourself, what's happening to the derivative graph? Well, the derivative graph seems to be having a negative slope there. Okay, so when you're concave down on the original graph, the derivative will have a negative slope. Okay, so let's write that down. F of x is concave down when the derivative graph has a negative slope. Another way of saying negative slope is decreasing. All right, so we just got to find the regions where our question graph right here has a negative slope. So we have a negative slope from in the interval from A to C. In that region right there, that's clearly a negative slope. So we're between A and C. So the answer here will be between A and C, because that's the region where we have a negative slope. Okay, let's move on to the next one now. Okay, I'm now moving on question number 3, and for question number 3, I need to find all x values where the graph of f of x has a relative minimum and a relative maximum, and I need to justify my answer. Okay, so in order to justify the answers here, it's probably best to go to your cheat sheet here. Here is your original graph, and here is your derivative graph. And on your original graph, let's go ahead and find the relative minimum first. So over here, on my original graph, here's a relative minimum. And let me just label that as minimum, M-I-N. And ask yourself what's happening to the derivative graph. Well, I'm going from below the x-axis, and I'll say below here. I'm going from below the x-axis to above. This means I'm going from above the x-axis. Okay, so the justification is this. When I have a relative minimum on the original graph, my derivative graph, first of all, it has a x-intercept, and on the left-hand side, I'm below the x-axis, and on the right-hand side, I'm above the x-axis. Okay, so let's write that down. A relative minimum, I'll say RM for short, a relative minimum happens when f prime of x, the graph of the derivative, it goes from below to above the x-axis. So that's the justification, and now we need to find that pattern on the original question here, which I'm boxing there in purple. So I believe that answer has to be the point D, because that's my x-intercept, and I'm going from below, and I'm going to above, right? So that has to be, the relative minimum happens when x equals to D, letter D. Okay, and in order to find, let me just erase this now, and now we need to find the relative maximum. And the relative maximum, if I look at my cheat sheet right here, here's my relative maximum right here. And if I go straight down, there's an x-intercept, and I go from above the x-axis to below the x-axis. Okay, so I'll say a relative max here. Relative max, max, happens when the derivative graph, f prime of x, and now it's just the opposite. It goes from above to below the x-axis. And that's really easy to find on the problem graph here. Let me just erase all this now. And that should be at point B, right? So at point B, you'll notice that we're above here and below here, and right over here we're below on the right-hand side. So that answer happens when x equals to B. And that should be it for that particular question. Okay, then I'm going to move on to question number 4 in a sec. All right, so for question number 4, I need to find all x values where the graph of f, the original graph, has a point of inflection. Okay, so just remember, we're given the derivative graph, and in order to find the point of inflection on the original graph, we would probably go back to our cheat sheet to find the general rule or justification here. And on your original graph, ask yourself, where's the point of inflection? Well, if I look at my second derivative graph on my cheat sheet, the point of inflection happens when x equals to 0 on the second derivative, and then I can just follow that straight up. So this right here is my inflection point, and that makes sense because on the left-hand side, that's concave down, and on the right-hand side, that's concave up. So that's approximately right where the inflection point is. Now ask yourself, what is happening on the derivative graph here? Well, it looks like I'm going from that blue region is a negative slope. And if I take a look at the right-hand side, this purple part, it seems like that's a positive slope. Okay, so what that means is the original graph has an inflection point when the derivative, f prime of x, it basically changes sign. All right, so when I say it changes sign, it literally means it goes from a negative slope to a positive slope, or vice versa. It can go from a positive to a negative slope or a negative to a positive slope. So we just need to find that on our derivative graph. So let's go back to our original question here. Here's the derivative graph, and ask yourself, where do I change slopes? Well, I change slopes at the point C. Right? Because on the left-hand side, this slope here is going to be negative. This is a negative slope. And then on the right-hand side, this blue region, this is a positive slope. All right, so the x value, x equals to c, that's where the derivative changes sign from a negative slope to a positive slope. So there's your answer, and there's your justification there. Okay, let's move on to question number 5 here. For question number 5, I don't think there's any tricks here. I need to find out where the derivative graph, f prime is f prime is increasing, and since I'm given the derivative graph to start with, I'm just looking for the region where I have a positive slope. And that's it. And the positive slope here is between C and E. That purple region, that's the positive slope. So I'm between C and E. Okay, and that would be it. I don't need to have the equal signs there for slopes just because at the endpoints we don't know if the endpoint is exactly positive or negative, so we don't need to include the endpoints there. Okay, and then let's move on to the very last question for this particular problem. This one also doesn't have any problem areas here. I need to find all intervals on the graph of f of x, which is this graph right here, and I need to find out when we're concave up. And concave up is just happening from here to here. That's concave up. It's the parabola that's opening up. So I'm between B and D. So x in the middle, less than sign, and that's it. Okay, let's move on to example number 7 now. Okay, so example number 7 is slowly becoming a little bit harder now because in this particular problem, we're given the second derivative. Okay, so if I'm given the second derivative graph, I want to find all x values where the original graph has an inflection point, and then I need to justify my answer. Now, once again, I think you should definitely look at your cheat sheet here. Usually the cheat sheet can help you figure out what's happening. And let me do that. Let me label the graphs here again, f of x, f prime of x, and f double prime of x. Okay, so I need to figure out when does the original graph have an inflection point. Okay, so the inflection point happens when the second derivative is equal to 0. So that's this point right here. And then let's just follow that straight up. Okay, so there's my inflection point right there, right? So the question is, when does this inflection point happen? And what's happening to the second derivative graph? Because that's the graph that I'm given. Well, what's happening is I'm going from below the x-axis to above the x-axis. Okay, so if the original graph has an inflection point, which is this point right here, then the second derivative graph, it behaves in a way where the graph is going from below the x-axis to above the x-axis. So let's go ahead and just write that down here. So f of x has an inflection point when the second derivative graph goes from, I'll say, below to above the x-axis. And that's the pattern that we need to find on our purple graph right here. So we got to find the regions where the graph goes from above to below. Here's one right away. This is below to above. So at the point x equals to b, that has to be one of the answers. And let me just erase that. And another answer here is at d because I'm going from above to below. So another answer has to be x equals to d. And I think that's it. I don't see any other points where I'm going from above to below or below to above. So that's it. X equals to b and x equals to d. Okay, let's move on to the next question here. Question number 2. And for question number 2, once again, let me just shrink this down here. For question number 2, I'm given the second derivative. And if I'm given the second derivative graph, I need to find all intervals on the original graph where it's concave up, and I need to justify my answer. Okay, so once again, I'm going to go back to my cheat sheet here. I'm getting tired of saying cheat sheet all the time here. Okay, so if I look at my original graph, ask yourself, where am I concave up on this original graph here? Where am I concave up? So it looks like I'm concave up in this region right there. Okay, so there's my inflection point. And let's just follow that straight down. And ask yourself what's happening to the second derivative graph. Well, the second derivative graph is just above the x-axis. So let's write that down. What that means is f of x is concave up when the second derivative graph is above. It's above the x-axis. Okay, and then after that, we just need to find that in our problem graph now. So I'm just erase all this just to clear some space up. So here's my graph. ask yourself, when is this part above the x-axis? Well, I'm above the x-axis in one region only, and that's from B to D. So from B to D, that's where I'm above the x-axis. So let's write that down, B to D, x in the middle, and the inequality signs will point that way. And that is your final answer for that particular problem. Okay, let's move on to the next question here. Question number 3 is very similar to question number 2. So once again, I'm given the second derivative, and if I'm given the second derivative, I want to find all intervals where the first derivative is increasing. So when is the first derivative, when does it have a positive slope, and I need to justify my answer. Okay, so once again, let's go to the cheat sheet. So this is the original graph, this is the derivative graph, and this is the second derivative graph. Okay, let's ask yourself, where is f prime of x increasing? So f prime of x relates to this graph here, and I'm increasing in this region right there. That's when I have a positive slope. Okay, and then if I just go straight down to my second derivative graph, what's happening to my second derivative graph? Well, that just means I'm above the x-axis. Okay, so this means I am above the x-axis. So I can say f prime of x is increasing. It's increasing, which means positive slope, when the second derivative graph is above the x-axis. So we just need to find the regions where our question graph here, when is that above the x-axis? Well, it's above the x-axis from B to D. So that's the same answer as to question number 2. So when I'm between B and D, that's when I'm above the x-axis. Okay, let's go on to the final 2 questions here. All right, so for question number 4, let me just kind of blow this up again. I think the last 2 questions we have to do, we need to change our thinking just a little bit here. All right, so for question number 4, I need to find all values of x where the first derivative has a relative max, and I need to justify my answer. Okay, so just to recap, I'm given the graph of the second derivative, and if I'm given the graph of the second derivative, I want to find all values of x where the first derivative has a relative max. Okay, so I'm going to try to use my cheat sheet here again to see if I can figure out the relationship. And there's going to be one little problem here. If I look at my first derivative here, whoops, I'll use a blue color here, I'll use green here. If I look at my first derivative, which is right here, I need to know where it has a relative max. The problem is on my cheat sheet, I don't have a relative max on my cheat sheet. In fact, I have a relative minimum here. Okay, so if I have a relative minimum, maybe I can use that to help me figure out what's happening in order to get the relative max. Okay, so if I have a relative min right here, ask yourself what is happening to the second derivative graph. Well, it seems like the second derivative graph, I mean, it's going from below to above the x-axis. Okay, so let's think about that. So if f prime of x, if I have a minimum, this implies that the second derivative has to go from below to above the x-axis. Okay, so the question is asking for a relative max, right? So you just need to use your little discovery here, and you just need to switch around the results here. So if f prime of x has a max now, I mean, the second derivative is just going to change the behavior. I'm going to go from not below, but I'm going to go to above to below the x-axis. All right, so that's the justification you need to find out when the first derivative has a relative maximum there. Okay, so let me just erase this statement here, and let me erase that. Let me just give myself a little space here. So on my question graph here in purple, I want to find the regions where I'm going from above to below the x-axis, and that's where I'll have a relative maximum, which was the question here. Okay, so I think one region here has to be the point D, because I'm definitely above. This is above here, and below it, this is the part where I'm below the x-axis. So I believe x equals to D would be my right answer there. Okay, so for this particular question, I would use the cheat sheet to figure out what's happening when you have a relative min on your first derivative and see what's happening to your second derivative and just reverse the results in order to find the relative maximum. Okay, so we're probably going to use that exact same strategy on the very last question too here. And for the last question here, I'm given the second derivative, and I want to find all intervals on the first derivative where it's concave down, and I need to justify my answers. Okay, so if I use my cheat sheet again, here is the original function, here is my derivative function, and here's my second derivative function. Okay, now the problem here once again is on my first derivative graph, is it concave down? No. If I take a look at this part right here, this part is actually concave up. Okay, so maybe we're not addressing the question initially, but maybe I can use this result to help me to figure out what's happening to the second derivative, or the second derivative when the first derivative is concave down. Okay, sorry about that. I was kind of blabbing on there, but if the first derivative is concave up, that generally means that the second derivative has a positive slope. Okay, so let's think about that. So if f prime of x is concave up, CU, then f double prime of x has a positive slope. Okay, now let's just see if we can use those results to just kind of switch up the answers now. If f of x is concave down, then what that means is the second derivative has a negative slope. Okay, so let me just erase this now. Erase all that. So when is the first derivative concave down? Well, it's concave down when the second derivative has a negative slope. So on our question graph here, we just need to find the regions where I have a negative slope, and that would help me finish off the problem here. So where do I have a negative slope? Okay, so I have a negative slope in this region from C to E. Okay, so C to E is one region where I have a negative slope, and I also have a negative slope between F and G. So between F and G, so I should write that as F less than X less than G. Okay, so there is my final answer there. I'm going to erase all this. There's my justification, and here is my final answer there. Okay, so that was a very long video. Anytime you need to justify things, you do need to take a little bit more time to explain what's going on. Make sure you understand your cheat sheets. It's pretty easy to generate this simple parabola here, graph its derivative, and graph its second derivative, and then this is what you should be memorizing, and then because that's not hard to memorize, and then you should use that whenever you're solving these graphing questions here. Okay.